Wednesday's lesson, when we went over 3.3, was all about adding and subtracting functions. So there were some very basic ones, like we saw in the very beginning, like with the notes. And then we also did some that involved a little bit more difficulty, like plugging in numbers and expressions. So the very first one, the very first type that we saw is just if they had given us a couple functions and told us what specific operation to do with those two functions. So this is asking us to find g of x minus f of x. So they're asking us to subtract these two functions, and we just have to make sure we write it in the correct order and watch out for any distribution that needs to happen, particularly if I'm doing subtraction. We have to remember to distribute the minus like a -1 out front to everything in the second function. So we've got g of x, which was negative x squared minus 1 minus 2x, and we were subtracting f of x, which is x plus 5. There's nothing to clean up in this first bracket. There's no like distributing, no combining like terms. There's nothing to clean up in the second function either. So now we are going to proceed to distributing the minus sign as if it were a -1 being multiplied by both terms in the second function. So what we've got now that we have distributed the negative as a -1 times x would give us negative x or minus x. -1 times a positive 5 is going to give us a -5 here. And so combining like terms, I have a negative x squared. Then we have a negative 2x minus x, which gives us a negative 3x. And then we have a -1 minus 5, which gives us -6, and we can go no further because there are no more like terms, and I cannot solve for any of these variables. The next kind we saw was similar, but now they started giving us values to plug in first, so we were kind of building on some of the past knowledge of how to use function notation and what it means when they put a number in a parentheses. It means I need to replace all the variables in the original function with that number, or eventually expression. So f of 4, I'm going to take f of x, which is 4x minus 3, and where there used to be an x, I'm going to replace it with 4. I'm going to be subtracting g of 4. So g of x, everywhere there was an x, I'm going to be replacing it with a 4. And I'm going to completely clean up each individual function before ever trying to do the subtraction. So in our first function, it comes out to be 16, and then 16 minus 3 gives us 13. Our next function comes out to be 4 cubed, which is 64, plus 2 times 4, which is 8, which comes out to be 72, and then 13 minus 72, I believe, comes out to be -59. Let's double check just in case. So 13 minus 72, yes, it is -59. And then that's our final answer. This time we could go all the way down to a number because we had some things to substitute. Last time we couldn't because they were still variables in our answer. The very last kind of example that we did on 3.3 was if they gave us expressions to substitute instead of just a number or the function itself. So they're giving us g of a, h of a, and asking us to find h of -4 plus a minus g of -4 plus a. So I'm going to set up the h of a first, which was -2a minus 5. I'm going to be subtracting g of a, which was 2 times a plus 2. And where the a's originally were, I'm going to be replacing them with what they have in the parentheses, which is a -4 plus a. Again, I need to completely combine like terms and distribute within each individual function first before I subtract. So I'm going to distribute the -2 in the first one, and that's going to come out to give us 8 minus 2a minus 5, which comes out to be -2a plus 3. In the next function, when we distribute the 2, we get, that comes out to be a -8 plus 2a, and then bring down the plus 2, which comes out to be 2a minus 6. And now that I can go no further within each individual function, I will now distribute this minus sign as if it were a -1 to both terms in the second function. So I've got negative 2a plus 3, now minus 2a plus 6. And so negative 2a minus 2a gives us negative 4a, and 3 plus 6 gives us 9. So that would be our final answer for our last example. And those were the really only types. We did look at some with doing common denominators, but for the most part, those were the main goals of 3.3.